I'm really happy to be part of this Mile High video conference for the 2020 edition, which is online. I really look forward to see all of you in person, hopefully by next year for the next Mile High video conference, and hopefully even sooner than that. For those who don't know me, I am Pierre-Louis Theron. I am the former CEO and co-founder at Streamroot. Streamroot was the company that's very focused on client-side video delivery technology, which is what we are going to be. I'm going to be talking about today. Last year, Streamroot has been acquired by CenturyLink. So about a year ago, we got acquired by CenturyLink, and since then, I'm now VP Product in charge of content delivery services. You might have noticed that a couple of months ago, CenturyLink has been rebranded. So we changed our name from CenturyLink to Lumen Technologies. And this is really the continuation of transitioning from being less a pure telecommunication company and more technology company. And the acquisition of Streamroot about a year ago is really a confirmation of that strategy. So what we're going to be to talk about today is really device side, delivery intelligence, and talking about mesh networking and multi-CDN networking from the client perspective and the device perspective. What has been changing from last year, where obviously a lot of things has been changing in the world and that has had a lot of impact in our industry. What we've seen is that the biggest spike has been really driven by some of the news and political events. A lot of political events during this year with the COVID-19 hitting. The sports was not happening for a few months, and the big political events has been really driving this. Stadium being empty, people going online and watching on their living room and watching streaming more and more to consume sports. So we've seen, again, very big spikes since sporting have been starting again. Obviously, we missed the Olympics and some of the competition like the Euro soccer competition in Europe and others that have been postponed. But since September, we've seen an uptake into streaming traffic. The last very interesting thing that happened is that stay-at-home order really put a lot of pressure in the network. And one of the pressure that we've experienced as a CDN provider and a mesh delivery provider is the peering saturation sometimes between the CDNs and the ISP network. And we also carry, as a big tier one ISP, we also carry a lot of the link for some CDNs, some other CDNs into the ISP network. And we see that link saturating, and we even seen some regulators calling us and to work with our customers and with the ISP to really improve this peering network, because a lot of people had to work home and they needed to have some good capacity at home. I'm talking about that because the technology we're going to be presenting today can be one of the solutions with, again, the client side technology that can help with this approach. So I'm going to jump right into it and kind of explain what is this about, the concept of client-side technology. So usually when you have a client backend streaming architecture, you basically have one device, and this device is downloading everything from the CDN or from the multiple CDNs that you have in place. What is interesting with the client-side approach, like first you can have a dynamic behavior. You can look at what's going on the device. You can look at the OS. You can look at the network. You can look at the performance of the device, and you can react dynamically, changing depending on the changing of the condition. So perhaps your CDN is saturated with your specific ISP, and that we can see it from the device perspective. So that's really one really big point. The second point is that we can react faster, because when you have an intelligence embedded in the client, you don't have to wait to ping any backend solution to make the decision in real time. You just look at what's going on in the player, look at the network condition, look at the device condition, and you can decide to change dynamically without, again, waiting to have a guidance from any backend solution or any DNS-based solution. So that's very, very interesting to have that reaction. The last one is where you can make more granular decision. Instead of doing decision based on an entire CDN, for example. So you see that one CDN is not working, and you're going to decide, you might want to decide to push all the traffic from this CDN to another CDN. Well, perhaps that's not the right approach. Perhaps you have one CDN that is saturating with a specific ISP, so it makes sense that the users that are on this specific ISP using this specific CDN switch, but it perhaps does not make sense to move all the traffic from one CDN to another, because you might actually create problem on the second CDN you're moving the traffic to. So per user tailored data, really, really interesting to have that approach. A lot of granularity when you have a client-side approach. So again, going back to how it works, usually you have one device here on the bottom of this slide, and you have one or multiple CDNs connected. With the client-side approach, we are going to present what we do when we combine multi-CDN with mesh networking, which implies peer-to-peer technology. So in that case, where not only you have the connection open with the multiple CDNs, but you also have a connection with other users that are watching the same on-demand or live content, where you might be able to pull the content from if it makes sense. So the first use case here is that basically what this client-side technology, it acts as some sort of proxy with the player. So you have the video player, we don't provide any video player. We have an SDK that is plugged within your existing video player. So we work with native video player. We work with HTML5 video players. I think today we support about 40 different players, so very wide range of video players and a very wide range of devices. Talking about HTML5, desktop-based, as well as connected TVs, as well as mobile, iOS, Android, as well as smart devices like Apple TV, Fire TV, Chromecast, and so on and so on. So this SDK basically gonna work in combination with the player. And when the player needs the next segment of the video, well, the client-side technology is going to act as some kind of proxy and analyze what is the best source available to get the content from. And in that case, for example, we see that you have connection with a lot of users that have the content available for you, and the best source to get a content is actually a combination of getting a few chunks from peer number 1, peer number 2, peer number 3, and peer number 4. That's going to feed up your HLS or Dash or Smooth segments before we actually feed it to the player. Bear in mind that we can download an HLS or Dash segments from multiple sources, not only from potentially multiple peers, but also potentially also competing from the CDN. So in that case, you see that the client side decided like, hey, I don't have, it's not better to go download the segment from the peer network and from the mesh CDN network. I'm gonna just download the segment from CDN-B. In that case, where you potentially started the first few segments downloading from CDN-B, and then you started to make connection with the other users, and you will be able to get a few piece of the content from peer 1, a few piece of the content from peer 4, and we can even complement a full segment by downloading a range request from the CDN to complete it. So really multi-sourcing depending on your network condition again. In that case, while you're downloading from CDN-B and you see that there's an error, like the client side is going to send a request to the CDN-B, but we're going to see the error rate increasing dramatically, where the client can react dynamically and you can do a mid-range switching without having to have any interruption in the stream and getting the next segment from CDN-C, because you know that CDN-C doesn't have any error, and you can switch from the second best available CDN on your CDN list. Again, this technology on the client side, CDN switching does not imply any manifest manipulation. We use the manifest that we receive from the CDN. It's done client side based on the performance on each CDN on the client. So we're going to be measuring the performance of all the CDN regularly on the clients. And we are not waiting to get any information from the backend to switch. So dynamically, we see there's an issue on the CDN, I have 4 or the throughput is going down, I can switch to the next available CDN, and I can also try to get the content from the mesh network as well. So a few use cases. I'm going to be focusing the use cases first on mesh delivery, which is the peer-to-peer technology, and I'm going to be talking then about client-side multi-CDN switching. So this is one customer example that we had during the summer. This big spike was actually a big political announcement where the prime minister were basically presenting to the country what is going to happen with the population. So a lot of people turn in and watch the content. This night we pushed more than 600 gigabits per second only with peer-to-peer in this specific country. What is very interesting to see is that, to give you a magnitude, this is a country where the top 3 CDNs in the country, so the top 3 CDNs that are the best interconnected, including Lumen, don't have more than 2 or 3 terabits per second each. So think about 600 terabits per second for just this event. This is a huge capacity that we can unleash to the network, and that we can free up the peering points during that event. So you see like a lot of users here, like 300,000 concurrent users on this specific stream, and 74% of the traffic that is actually delivered by the mesh. So 3/4 of the entire traffic was actually delivered by mesh. Very, very efficient during that spiky event. But what's also interesting that it's not only the offload, it's also the performance. What about the QoS? What about the buffering ratio? This is something that we really track on all the time with our technology, because we are switching to one or the other source, or we are switching CDN, or we are switching to mesh delivery. If we see that getting the content delivered by another CDN or getting the content delivered by the peer-to-peer network gonna actually provide us with a better QoS and less, which means less buffering and higher bit rate. In that case, what is very interesting to see is that the buffering ratio, it's actually going down as the traffic is going up. So the more users you have with this technology, the more sources you can get, and the less likely it is that you're going to experience video buffering. And this is very clear on that graphic, that when there's the ramp up here, well, there's actually a down in the buffering ratio. And usually it's the contrary, especially again when you are on a pretty constrained network, when the peering points are getting saturated, where CDN at one point going to either decrease the throughput and decrease the bit rate, or you're going to have some users experience buffering. This last graph is also very, very interesting, because you see that the comparison of the buffering ratio between peak time and average time. And you see that during the normal time, the buffering ratio is actually lower than during the peak time. Again, same thing, proving that during that event or during any peak event, mesh technology can actually improve the user experience. Last but not least, what's very important for us is that we really keep the traffic inside the ISP, and we see that again, the buffering ratio impact for each ISP was really dramatical. And on the second largest ISP in the country, where the buffering ratio was at least 14% less during the big event than during the normal time where you do mostly CDN. So again, dramatical impact of this technology. Localizing the traffic is really, localizing the traffic is great with CDN, because you're bringing the CDN closer and closer to the end user. It's kind of bringing that to the end user device. Not only having POP well interconnected in the network, but having client-side technology directly inside the ISP network and as close as possible to the end user. So this was the impact of the mesh technology, especially during these big events, especially during these big political announcements where millions and hundreds of thousands of people just turning on their TV to know what's going to happen next. I'm going to give a couple of slides explaining a little bit the impact of client-side decision making. This is one of our customers that basically have been deploying the technology within their player. And what you see here is that on a normal basis, they kind of weighted the different CDN with the majority of the traffic on the CDN one here, which is in green, and the second CDN is the one here in blue. What you see is that, well, some CDN can have outages. All the CDN can experience an issue either on one region or at a larger scale. And what you see here is that this customer their users didn't even notice the outage of this CDN. Because when the CDN went down, the client side, every client side technology actually noticed that one CDN was down because the SDK suddenly was receiving 4.4. The player was receiving 4.4. So what's the SDK done? That it just switched to the next available CDN, which is now the CDN in blue. And you see a big spike. And when the second CDN was up again, which was about 45 minutes, well, the players and the SDK just noticed that the problem was over, so we could just go back to the switch that was the split of CDN that was done at the beginning based on business metrics. So really, and here this is a screenshot of a dashboard, so you can monitor everything that happened on all the CDNs. And here you see that these had a big spike in error rates. So the error rates went through the roof with this customer. So we switched the CDN to the users to the next available CDN. Same here with more CDNs, another customer that has 5 or 6 CDN in the mix. And you see that depending on the performance, the split of the customer, of the CDN across the customer is changing dynamically, automatically, nothing to do, only done on the clients, and no interruption in the stream. So that's really the midstream switching is really something we are one of the only providing in the market. So really interesting approach. If there's again, if you have any questions about it, about how to implement client-side technology, we would love to show you more data, more use cases live, but also VOD. We have a lot of VOD use cases for this technology. And I'm going to let some time for the questions. Thank you very much.